Hey, welcome back. I'm checking on my YouTube stream. Looks like I am actually streaming this time. Making sure video is up. We've got audio. Okay, cool. All right, so I realized after I put up the last video that this, let's log back in, that this course tour never actually recorded. So I was just talking to myself, showing myself the course, but not actually presenting any of the information. So I'm sorry about that. It seems like the class is doing really well so far. We have people engaged in the online discussion on our GitHub page. Everybody made a copy, so a fork of this main computational mechanics website, which is great. We're up and running. Now the main thing that we're doing is working on homework number 1 in this first module. So I'm building this course tour now because apparently this thing never actually worked, or maybe it did. Let's see. Yeah, so this is my last video. Okay, so anyway. All right, so I'm updating this today. So now we'll get a better course tour. All right, so welcome to the course. You're already in it. You're working together. Hopefully you are meeting some other people in the class. So we have other people working here. These YouTube streams are all in my YouTube channel. So I'm just going to walk through some of the resources that we have for this course. This YouTube channel for ME3255 has everything from the winter session. It has previous lectures that I had done for in-person kind of troubleshooting sessions with people here on the Stores campus. Like in the fall semester, and it kind of goes back that way. You do not have to watch like all of these old videos. Sometimes we're working on the same problems and the same ideas, so sometimes these can be really helpful resources. If you do find something helpful, add a discussion post of like, hey, this video that I found from whatever, September 2024 was a great place to look at numerical error or something. So that's where this discussion post can really add a lot of help for everybody in the class, is when we start adding our own resources and talking about those kind of things. So anyway, that's this YouTube channel. It's the first link on our thing. Next link is our course tour, which is going to be this video. And then this, who is Professor Cooper? This is my own website. This is how you can book an appointment for office hours. This can be anything from, if you have questions specifically about this class, we could meet for half an hour or 5 to 10 minutes, however long you want. But by default, it's a half-hour block. We can talk about the class, talk about things that you like about it, or questions that you might have if you need some in-person help. Another link to just my general YouTube channel of all my classes, and then all the open educational resources that I've developed over the years, and information, like more information if you're interested in like how I think about learning and like places that I've talked about teaching and learning and engineering and these kind of things. And this is an ongoing thing that I've been doing with generative AI, since that's kind of changing how engineers work. Well, it changes how a lot of people work, but for engineers, I like to know what tools do we have and how does it make our job easier. So that's what I'm trying to do with this generative AI channel. Julia is another language, like similar to Python but different. Anyway, then we have our course syllabus, which it seems like people have already gotten to and you were reading about. we're talking about like expectations. So especially in this age of like generative AI, it's very easy to like generate code and kind of copy paste it and not think about it at all. So I do expect you to like copy and paste code. It's one of the core skills of programming that is not talked about a lot. You need to be able to find code that does what you want and put it in the spot where it needs to do the work. And that's just the way things work. Sometimes you'll have to write things yourself, like there's going to be a lot of connecting steps where you have to write those. If you want to post and share things, and then that's fine. But what you shouldn't be doing is taking things that you copy and paste, whether it's from other students, from Chegg, like answers and those kind of things, or even generative AI. You should not be taking that, pasting it in, and then calling it a day, just saying like, okay, it works, I'm never going to think about it again. Because sooner or later, I'm going to ask you like, why did you do it this way? Or so you need to be able to understand like what was the reason for doing something. And I'll show more examples of that as we keep going through the course, because right now it's kind of a general advice of like, don't copy paste without understanding it, but how do you actually understand it? So we'll keep working on that. So we have this main open educational resource that's kind of this website with the syllabus. All of you have made a copy of it, and you have your own GitHub forked repository of it. Fancy way of like saying like you bought the textbook. We're using this NanoHub Jupyter server, so we have access to Python and Jupyter. And if you haven't made a NanoHub account, then it's not too hard. Here, let's open this. You can click this sign up button, either sign in, make a Google account and sign in with that, or create a username and go through this. And then now you have access to our NanoHub resource, and we could go into our first module and start looking at the readings. And here, the main benefit of using like Jupyter Notebooks as reading material is that you can start changing things along the way. So in here, let's say you want to talk about your first program, and right now it's just Shift Enter will run the code. But if you want to change that, because I think by default every programming language starts with hello world. It's like the intro, how to use this language. We could change this and say hello name. Oh, can't spell my own name, I guess. If I want to start playing around with like, do I understand variables yet? And I think when I run that, yeah, it does this at first, just actually prints that out. So I'll put this F in here, so it actually inputs the name that I gave it. Kind of cool. And there's more than one way to do that, but this is a nice way of like plugging in some variables into a print statement like that with this like format command. I like the dot format for that too. Like this. Oh yeah, and get rid of this F. I know it's more typing, but I just like it. No specific reason. But I'm taking this notebook and I'm making it my own. I'm saying like, okay, well this is a print statement. How do I actually do something different with it? So we have, and then GitHub, this one, so GitHub is the main place where we're doing our discussions. So I'll pull up our discussion page. We've already started talking about like what are summer things that we like, and what's different code that we've used in the past, or maybe that we're just thinking about. So we're up and running on that. Make new discussion posts, and as many or as little new discussion posts as you want. It's it's a great way to connect with the whole class, and I'll keep looking at this each day to see what questions come up or what are new conversations. Cool. All right, so that's syllabus. Some of the, oh, actually, let's go back to syllabus, and we'll take a look at our grading. So GitHub discussion posts are part of the participation. You should at least have a GitHub account and submit that first GitHub discussion answer, and then there's also the piece of the participation it's based on the readings. So here I'm pretty excited about this because I'm playing around with how to use AI in different ways, but there's this reading coach that I designed through Copilot. That I used Copilot because we all at UConn have Microsoft accounts, and we all have unlimited access to Copilot. And I think I was showing this in the last video, but when you click on this, it brings you to this thing that tells you what it is, and it's this agent, and you can say open. And now I have my learning coach for module 1. So if you're doing the homeworks or you're doing the projects, then learning about a topic, this will give you like example code and kind of explainer code. I could even, here, let's go in here, go into numerical error, and we'll come down to free fall. So what I want to do is grab like some code that seems a little, so I'm just grabbing like a piece of code that generated this graph, and I'm gonna bring it into, I need you to explain this block of code from numerical error. And I'm gonna grab this one too. So the learning coach will look at what I told it to do, like learn about a topic, explain this block of code, and then it kind of steps through each piece. Another way to do this is look at the doc strings for each of the functions that are being used. But this has become a really powerful tool in terms of like making code more approachable, like getting some readable. Yeah, so it helps you visualize truncation and round off errors as the number of time steps increases. And yeah, that's what it's doing. There might be some other things that are not explaining as well. So in this loop, yeah, it's returning an analytical and numerical solution, that's what the comment says. So it's reading the comment and telling you what it says, but it's doing it, right? So that's one way to use this, but let's make a new one. Let's say I worked on the homework, I did the readings, now I want to do a reading quiz. So what I'll do is say, I need you to test my knowledge of module 1 and give me an A, B, or C. And then for some reason it always asks me, what is the purpose of a print function? And okay, I'll tell it. Print is used to display and format variable outputs and information in the console. Something like that. That's correct. And then what are special variables? Special variables could be, variables are objects such as true and false, or none that are reserved for Boolean operations and other functions. I don't know. I'm just okay, a list and a NumPy array. So what's the difference between lists and NumPy arrays? Lists are kind of are objects that store they store objects. Is that what I'm trying to say? Let's go with NumPy arrays first. NumPy arrays store uniform objects in a oh my god, I can't think now. I'll just say such as vectors and matrices of numbers, integers, even strings. Lists are similar but have no constraint on individual objects in the stored list. Something like that. And says that's correct. Oh, and then time. One last thing. So time is used to find how long the computer takes to run a block of code in Jupyter. So based on my answers, I demonstrated an A, which that's great. And what I'd really like for this is edit in pages. What you can do is grab these, add these things to a page like this. And I know this is kind of an annoying way to do it, but just grab all these responses and here, and now I have like this page of like questions that it was asking, and then all the outputs that it was giving me. And I don't think, it doesn't really show what my inputs are there? But anyway, so at least I can kind of see like what the AI is giving you and like how that's working. So now I think I can, no, I think you have to open it in Word. And again, sorry about like the multiple steps. At some point this will be an easier process, right? Okay, so now it creates like a Word document, and or even if you don't want to do that, here, if we just say like, oh my god, I want to like copy everything. Yeah, all right. I just want to copy everything. Copy this whole Word document, come into this assessment, and let me start a student preview so I can submit my own work. Coming in here, go into my reading coach and view the instructions. make a submission. I'll just paste in my questions, and then it also has this final response. You can add anything to this at all. So if it gives you these questions and then it tells you like, hey, your understanding is a C, let me know, like, give me some more information. Like, it gave me a C, like, yeah, let's. So, like, just give me some information about, like, you're the one interacting with it. You're the only human involved in this interaction. This AI copilot thing is not to be trusted at all. So I want to know how the interaction went, and if the back and forth that you had is not representative of the actual reading experience that you had, please let me know. I'm just interested from like a learning perspective, like learning journey perspective, like how helpful this is as a learning coach. So I'll submit this, and I don't need these submission receipts. If you want to download and keep them, you can, but I'm never going to ask for them. If something goes wrong with the submission, I'll take your word for it. So that's like the reading coach, and each module has its own reading coach. And I think it'll be really cool to see like how those things, how we interact with those, and how the answers get assessed by that AI tool. Cool. All right. And then on the last video, I was talking about like submitting these homeworks. So there's every module we have one homework and then one project. The main way to kind of interact with this, if I come back into our website, so every module has kind of a few reading assignments and then a homework. The homework is meant to be like collections of the readings. So you shouldn't need to like start from scratch and write 100 lines of code to do the homework. There might be a few places where you have to like search for things and figure out how things work, do some logic operations, but it's not, these homework assignments are not meant to like push you to create large code bases. And then in the projects, this is a place where you spend some more time like doing some creative assessment. So like in this first project, you're asked to like do a calculation and then turn that calculation into a function. There's a lot of different ways that you can do that, but I want to know like, what is your process? Like, how do you take like how do you take the calculations that you did, how you organize the variables, and how do you turn that into like a one-stop shop of like, all right, this is how I can do something, run the code, and get the output so I can use it in the next step. So anyway, that's kind of the breakdown between the two. Like, homework is based on readings, project is sort of a collection of ideas from this module to like demonstrate some understanding there. And that's our course in a nutshell. So far, so good. I'm excited for the work that I've been seeing and the questions that and the responses that we've gotten on GitHub discussions. I love working on this class. I love seeing people continuously improve their code through this class. As you're submitting these, I'll give you, so as homework 1 comes in tonight, and then tomorrow I'll review it. I'll give grades on each homework, and then I'll record a short video about like where I thought either we needed extra help or maybe there was something weird that came up. Like here, we'll go into homework 1, and let's just I'm going to take this and just give it to my learning coach, this FizzBuzz problem. So we'll come into Copilot, we'll make a new I'm going to just ask it about this FizzBuzz example, and we'll see what it comes up with. So it's giving me some example code here, and it's using if, elif, 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 and then an else command, and it's creating a result first, and then going through here. And I know I didn't actually explain what this was, so let's take a look at what we're trying to do with this. FizzBuzz problem is something where normally in an interview, the output that you're expecting is 1, 2, 3. 3 is divisible by 3, so you write fizz. 4, 5. 5 is divisible by 5, so write buzz. 6, divisible by 3 again, so fizz. And then 7, 8, 9, 10, 11, 12, like fizz, buzz, fizz, buzz. But when we get to 3 times 5, which is 15, it's divisible by both, so we want to write fizz, buzz. In our case, what we're trying to do is write computational mechanics and rocks for 3, 2, 5, 5. So let's take a look at this. I'm going to copy this code and see how it works. Let's just make a new notebook. Select. And I'm just running it on my own computer. You could run it in your... And what we did, at least what the AI gave us, was this FizzBuzz custom. And I don't really like that name. Comp mech rocks. I like that better. Comp mech rocks. So yeah, I just didn't like it. So let me change it because I wanna define it my own way, right? And right now it's creating a function. It initializes this result as an empty list, and then for 1 through whatever range end I give it, so in this case it was 20, it's going to go 1 to 21, which means 1 up to but not including 21, and then go through and check each of these cases. And I don't think this is going to work. Computational mechanics, because 30 is divisible by 3, 2, and 5, so it should give us computational mechanics rocks, but it's not doing that because it's one of the results is not computational mechanics rocks. So we actually need one extra and then this should really be an elif, right? Because we need, at least the way, if I'm going to use if and elif, the way that I need to do that is be able to tell it, like, all right, this is the most specific case, and then step down into the less specific cases. So that's why these last 3 are showing %3. And the reason for that is that elif, these things do not get kind of activated, like it doesn't actually reach this step if this is true. So if this is true, then it skips everything below it and goes straight into this and skips the rest of the loop. If that one's false, but this one is true, everything else gets skipped and then gives me that result.append. And I'm not a huge fan of appending things into a list. I just don't like when lists are changing shapes. So I'm going to initialize my list. Result is, oh yeah, arrays get kind of weird with lists. Let's see. Since we're using Copilot, let's say, how do I initialize a list to a given size? Okay, so I could do this. It's just like do a little list comprehension. And then replace it that way. I prefer to do that. And then I like to say bracket. I'll say num -1, like that. So instead of appending something, just the way I like to do stuff. So let's see how this one works. So it still gives me the same result, right? But now I actually get that computational mechanics rocks in there whenever I get to 30 because I added that extra if statement here. And I don't love that it's printing things out like that. So what I'm gonna do is for So I'm just changing the output. So it was giving me a list of stuff, but I don't really want to look at it in a list format. I want to look at it this way. And what I could even do is say I comma, and what I'm thinking of, for I comma entry in enumerate. Enumerate is an awesome function inside of Python where it gives you both the index and the value. So in a lot of programming languages, you always have to do a for loop over a given like set of numbers. Like it has to go from 2 to 20 or something. But in Python, you can do loops over anything you want. Anything that looks like a list or a tuple or an array, you can grab each value inside of it and run things that way. But then sometimes you also need like, where did it happen? So in this case, I need that I. So I'll print I+1 and entry. And now I can see like 30 is compmech rocks, 21 is computational because it's only 3. And then in here, number 10 is both 2 and 5, so mechanics rocks. So it's doing what I want it to, right? Like the 3s, the 2s, the 5. So here's my 2, there's my 3, here's my 5. Everything's looking better now. So that's an example. This is an example where I'm using AI it's doing what I asked it to. Like it's not that this code is wrong, but it wasn't doing exactly what I wanted. It didn't have this first one, and if I didn't know anything about Python, then I would just think like maybe I just need to generate it again. But it's probably going to miss it the next time too, or maybe sometimes it won't miss it. So I'm taking the result that I get, looking through line by line, and then this is also something that it's better practice to initialize variables so that you know what the variable is when you ask for it. And yeah, some people have different ideas about that, but when you know, like in this case, if I'm asking for 30 values, like, or if I'm asking for 31 values, I know exactly how big results should be. I don't need to create like an unending loop that is just slowly changing the size of this list each time. Okay, so anyway, I mentioned that I'll use AI and kind of give some tips on how to use it properly. This is one of them, is like take some time, think about like how would you do it? Why is it doing that way? It's not doing things the best way. It's not even doing things really a good way. It's just taking lots of results and sort of jamming them together, and maybe it works. Most of the time it seems to work, but it doesn't always do exactly what you want it to. So take a look, think about it, criticize it. It's your work. When you copy paste this, you have claimed ownership of it. So is it something that you want to put your name on is the main question. Okay. And it even helps, like if you copy paste this and you think it works and maybe you have questions about it, just add a comment like code from prompt to Copilot, not sure how to initialize lists, but gave it a shot. And that's a good way to like say, now I know I'm not debugging your code, I'm debugging Copilot code, or ChatGPT or Claude or wherever you happen to be, like if you're working with AI, generative AI, then keep it in the loop. Like give it some credit and say like some of this is coming from other places. Cool. Anyway, that's what I had for today. Now we actually have this course tour, so I'll update this, and we'll keep working on homework 1, and then on tomorrow I'll return it. You can take a look at any feedback I give you, and if you want to revise it, you can revise it and resubmit, and I'll give you any of the points that I had taken off back.